Hello. So this lesson is going to be on visualizing in 3D. Okay, so remember in the Engineering 25 classes, there were 3 ways of representing a 3-dimensional object on a 2D paper. And one was doing so by using what is referred to as oblique drawings, where your axes is here and here, and the front plane is perpendicular to your line of sight, and then you draw the depth off at 45 degrees. The other way is to use what is called an isometric, where first you start this line, you're going up 30 degrees, going up 30 degrees, and then you are seeing your object all sides on true. So let's just say, this is our front face, this is our horizontal, and this is our profile, and this is our front. On an isometric, we're always seeing, this is off at 30 degrees. We're always seeing the front on the left and then the profile to horizontal. Now, whichever one you're more comfortable with, that's the one you could draw with. I've always been drawing, since I'm a kid, blocks using oblique. So oblique is quicker for me. So that's what I'm going to be looking at. In statics, I already said this in the other video, but I wanted just to relay it again. You're going to see 2 different kinds of representations of your axes. You're going to see X positive to the right and Y up, and Z coming out at you. And what this is showing is the XY plane is this vertical plane, and your X is coming towards you. The other thing you're going to see is you're going to see it written as X-axis coming out at you, Y-axis, and the Z-axis. Sorry, and the Z. And the reason for this is, in this case, your XY plane is the horizontal plane, kind of like your north, south, east, west axis and plane. And then Z represents elevation. So on all the statics problems, you're going to see them either using this 3D notation or this 3D notation. And you'll get to choose which one you want to use as well. Just make sure that you are labeling where X, Y, and Z are. Okay, so now the next thing I want to show is that sometimes some students have an issue seeing something in 3D. So this is page 1. And here is page 2. And what I'm going to do is just hide something to begin with. So in this case, the first thing you're doing when you're looking at a 3D object is first see where your axes are. Here's my X, here's my Y, and here's my Z. So now I'm knowing that the XY axis plane represents the horizontal plane and Z is going up. And here's a force F that's given, and it's given from point A to point B. So first I'm going to do this more visually to find the components of that direction of that force, and then I'm going to do it a little bit more mathematically. So again, I'm looking at A, and I'm going to B, and I'm looking at the x-axis first. Can you notice that A is in the middle bottom right of the box, and it's going to the top right, the top left back. So it is going back. So you know, going from A to B, you're going in the negative X. How about in Y? Going from A to B, you're going really towards the left. You're going in the negative Y. And in going the Z, it's going up. It's going in the positive Z. Does everybody see that? The one that might be a little challenging is the X. Just realize that here's the front face of the box. A is the middle plane of the box, and B is in the back. It's going from A, the middle plane, to B. It's going in the negative X. So now let's figure out what is the distance it's going. Well, going from A to B, I've given you all these dimensions, right? So 3 represents the total width of the box, 4 represents the total height of the box, and the total depth of the box is 2, but A is starting halfway back. So if we're going from A to B, we're going -1 in the X. If we're going from A to B, we're going, A is on the right side, the right plane of the box. I'm going towards the left. The total width is 3. So from A to B in the Y, I'm going a -3. And going from A to B in the Z direction, I'm going a +4. So the direction, the distance from A to B, and I guess I could put a little thing on it to show it's a vector. It's going in the -x direction 1, it's going in the -j direction 3, and it's going in the +4 direction in the Z. Okay, and as time goes on, you're going to get more comfortable with seeing this in 3D. I mean, graphics definitely helps, but then statics helps even more. Okay, but now I want to look at it another way, more mathematical, which you might be more comfortable with to begin with. So let's look at the coordinates of A and B first. So what's the coordinates of A? For X, it has a coordinate of 1. In Y, it has a coordinate of 3. And in Z has a coordinate of 0. So the coordinate of A is 1 in the X, 3 in the Y, and, oh, I'm sorry, and 4, did I say 4? I'm sorry, 0 in the Z. Well, what about B? What are the coordinates of B? In the X, it's 0. In the Y, it's 0. And in the Z, it's 4. So if I was trying, and let's just check what I did already. I got 1, 3, and 0, and B is 0, 0, 4. If I wanted to find the distance from A to B, it's final minus the initial, right? So the distance from A to B is B, which is the final point, to the initial point. So the final in the X of B, this would be BX minus AX, this is BY minus AY, and this is BZ minus AZ. And it comes out to be the same, -1I, -3J, plus 4K. Let me just move this up a little. So going from A to B, it's final minus initial, BX minus AX, BY minus AY, BZ minus AZ. And it comes out to the same value. Hang on a second, let me go up a little bit. Comes out to be the same, -1I plus -3J plus 4K. So either way works. This bottom part takes more time. It might be a little bit easier for you because you are comfortable finding components of points, coordinates of points already. You've done that so much. This might be a little harder for you to actually picture it in 3D, but I urge you to do this as you go along because you're going to get better practice and you want to be able to see things in 3D. Imagine if you're designing a bike or a building, you want to be able to look at it and see it in 3D. So you need more practice in 3D. Okay, so what I just showed you in the video is I started out by showing you that when we're looking in 3D, we could use the oblique or the isometric, whichever one we're more comfortable with. I tend to use oblique. There are 2 different arrangements of the 3 axes, X, Y, and Z, where X and Y are on the vertical plane and Z is coming out at you, or X, Y is on the horizontal plane and Z is going up. And then for you to be more comfortable with components, finding, not components, coordinates, the direction that a vector is going. Okay, thanks.